Hello everyone, my name is Barik Firmansyah. So I will be presenting the product of my final project entitled Graph-Based Clustering and Pilot Assignment for Scalable Cell-Free Massive MIMO Systems. So here's the block diagram of my product. It's basically a software, a GUI software, graphical user interface software that takes a number of inputs such as the number of UEs, number of ABs, the maximum traffic limit of each AB, and the coverage area. And then for the system, we have three stages: anchoring stage, UE exploration stage, and the pilot allocation stage. And the output, we could see the graphical user interface, the location of each AP and UE, and the cluster and its color. So the color represents the pilot. So different color means different pilots. So here's the demo of the software, the GUI software. So here is the clustering algorithm. In the cluster generator tab, we can modify and change basically there are 4 parameters here. We can generate the layout here. So there are several shape here: circle, square, and star. So here the star represents the UE, the circle represents AP that is serving UEs, and square represent the AP that doesn't serve any UE. And we can also see the AP clustering data. We could see AP1 is serving UE5, and it's located in this X and Y axis. And we can see also the pilot, which is allocated to UEs. We have 10 APs here, and so we have 10 AP data. And we can also see the UE data, which APs are serving these UEs and what pilot is assigned to this UE. We can also plot the spectral efficiency. Here we have the number of UEs. We cannot pick the number of UEs outside these values. It's a predefined number, so 10 and 60 and up to 400. We can also see the 95% likely per user SE here. We can see that our proposed algorithm outperforms the existing algorithm by 60% here when K equals 400, when number of UEs equals 400. And then here's the number of pilots required to assign during the graph coloring algorithm, this outer algorithm. Pilot. So here we can simulate the spectral efficiency. Unlike the previous this one, we couldn't simulate the number that we want, but in here we can see we can change the parameter whatever we want. For example, we can see here with these parameters. Note that the longer, yeah, we can see here the graphic is not so smooth because the setup is only one. And we can increase the number of setups, but please note that the bigger the number of setups, it means that it will take a longer time to simulate. And then we could also see when the number of setups is 2, the plot is smoother here. So it is smoother, but it will take a longer time to simulate.